Welcome all. Max of the Accidental Engineer here. Today we're joined by Tom Alcorn, software engineer, backend software engineer at Flux.io in San Francisco. Do you mind sharing for our audience what you do there and what Flux does as a business?
Yeah, totally. So like Max said, I'm a backend engineer at Flux.io. Mostly I work on backend services, so writing services and APIs that enable our front-end teams to offer new platforms and apps to our customers. The actual company itself is focused on architecture and construction users and provides kind of like data services for that field. So construction and architecture has really large data problems. Building models just one sort of like segment of that problem. It can be like these huge files that have to get shared between huge teams of people at like construction firms. So that's kind of the problem space that we're trying to address, and specifically one of the things we can do is like take your geometry from whatever like CAD tool you're using and provide it to any other CAD tool that you're using.
Got it. CAD being
computer-aided design, yeah, or computer-assisted design, I guess, depending on.
Right on.
Yeah.
Well, it would be probably helpful for our audience to know how we know each other.
Yep.
We met on the job, working for the same employer in Boston, a startup called EverQuote, or now called EverQuote.
Yep, previously at Harmonix.
Previously at Harmonix.
They don't want us to say that, though. So.
Oh, for sure. So that was your first job out of college. You went to MIT, and you, like many, or by and large, most of the guests I've had on, did not major in computer science. So for our audience that has a similar background to you and not having gotten a computer science degree, how did you get that first job that was involving programming and whatnot?
Yeah, just pure luck, actually.
For real?
So the first line of code I ever wrote was in freshman year at college. So I'm not like the kind of person who was coding since I was like a kid or anything like that. I took a Python course freshman year. I didn't really touch, I touched software obviously all the time. Everyone uses software all the time, but I didn't write any software myself until senior year when I decided to take some computer science courses right at the end of my degree to try and have something to be able to go to an employer and say, hey, I can actually do a job that involves some amount of coding. So I was a mathematics and physics major in undergrad. I studied like a lot of solving equations by hand, that kind of thing, not that much software. The closest thing I would say is writing lots of MATLAB scripts to analyze data with,
For sure.
which is a very handy skill and actually not totally unrelated to what I ended up doing at EverQuote. But yeah, not at all a production level software engineering type of skill set at that point. So
what was the kind of crossover? You mentioned learning MATLAB in undergrad, but what was kind of the crossover from your math and physics classes to that first job out of school?
What do you mean by crossover?
Were there things like MATLAB that your undergrad education gave you that you actually managed to use on the job?
Yeah, I guess so. Maybe not directly, like I said, mathematics and physics courses, I guess the fundamentals in mathematics and physics are applicable in a lot of different fields. So, at EverQuote, I was doing kind of data analytics / data pipeline building role. So, learning the basic, the fundamentals of mathematical inquiry into a problem was helpful in that regard, I would say. But, I think the small amount of Python that I picked up while in college was helpful as well. That was the main language that we used there. That would be it, I would say, though.
So it sounds like there were some hard skills that you obtained as soon as you started that first job.
Yeah.
For doing stuff like backend engineering, data pipelines.
Yeah, definitely.
What were they?
I think first of all, just taking programming and software engineering to the next level from writing scripts that do data analysis and basic little intro class level stuff to this thing actually has to run and not mess up constantly and
Sure.
We're going to be depending on this, and not only that, it has to sort of interact with multiple other systems all at once. So I guess it's a kind of generalized idea of like dependency management and knowing what this piece of software that you're writing is, what kind of environment it's going to be in. I think one thing about scripting, right, is you know what environment it's going to be running in. Like you're going to, run it on your own machine, probably like hit a button, the files are all going to be there and it's going to do something. Like that's a typical data analysis kind of workflow. At least it was for me when I was, doing experiments in undergrad. But in a production environment, like, your script's going to be running on some machine that you're not like directly logged onto, right? Like it's, somewhere in the cloud or something. And it's going to be talking to these other services all over the place. And they're also like, you don't really know where they are or what they're doing. So there's a lot more, you have to do a lot more thinking about the environment that code is going to be executing in.
So what were some of the steeper learning curves in that first job when it came to knowing the environment your code would run in?
Yeah, probably like one thing that I really feel like I suffered from was not having a clear mental model of like how a modern computer works kind of from the ground up. And I don't think you need to have a perfect, like, complete understanding of a computer to be a good software engineer, but I think, like, understanding a lot of the basic things about, like, what an OS is, like, what a kernel is, what is the networking stack doing, like, just having some basic kind of mental models of what's going on there can help you a lot. And a lot of that stuff bit me multiple times before I had the realization that, I'm actually running into the same problem over and over here. I should actually just like do some research now, read about this, go on Wikipedia, like start somewhere.
Sounds like there's some specific anecdotes. Are there any specific ones that you can give us about how you had a problem in your first job out of school that arose from not being familiar with how modern operating systems work?
Interesting. I can't really think of any totally off the top of my head.
Sure.
But I have like the emotional memory of like,
For sure.
I feel like every software engineer has had this, of
yeah.
just like banging their head against a thing, like why won't this work? Why is it not doing what I expected it's supposed to be doing?
Mm-hmm.
Yeah.
Sure.
Yeah.
No, I mean, I can relate to that experience for sure.
Yeah, I mean, if you can't, then like, it's it's ubiquitous. Everyone's had this moment from like, Linus Torvalds, like, amazing software engineers all the way down to like total beginners. It's a universal thing.
There's, as you start programming for the first time in a job role, you're always working with abstractions where there's details below the surface of what you're doing, like you're describing what the operating system or kernel is doing. And you might not know exactly. You might not know the tools for observing what is happening beneath your layer of abstraction.
That's a really great point.
It's like you said, looking or going to Wikipedia and reading about this stuff is like populating your cache, so you don't have to look another time. So there's a constant trade-off in your first job about whether you should just keep chugging and trying to beat the abstraction into submission, or should I go spend God knows how much time, maybe a full day, a full work day, reading Wikipedia article and all of its links.
Yeah, exactly. Yeah.
On that topic about learning this stuff on the job, what were some of the resources you used to self-teach? Coming from math and physics background and doing a little bit of MATLAB and Python in undergrad, how did you get up to speed so quickly? Like, was there a real safety net for you in that first job to educate you about the skills that the employer needed, or?
I think like the people around me in the work environment definitely had a lot of good pointers. Like one great thing about that job was that people were super open and receptive to questions and like willing to explain things to a like relatively fresh, like green kind of employee. So that was definitely great. And kind of absorbing almost by osmosis, like what people are saying about things also helps a little bit. Like you might not even realize, that it's happening, but slowly you pick up like words and concepts just from the way people are using them, which can help link together things that you've seen while you're actually working. So that was definitely really good. YouTube videos, like there's tons of them. I can't even really name channels or anything like that because I feel like I've just so many times like gone to YouTube and like, what is this thing that I just learned, like this word that I just learned exists, like what is that? And then click through a couple of different videos and try and get a sketch of what it is. Wikipedia obviously is a great resource. Stack Overflow is a great resource. Another good thing to do is sometimes to just kind of like a website like Quora is reasonably good for this, of just looking for a kind of slightly more general question, like, how do modern compilers do optimization or something? And it's not like you're not looking for one fact, you're looking for kind of a set of answers that are a little broader and more open-ended, but that can be an interesting way to find new niches of knowledge that can help you sometimes.
This is a very common refrain so far in interviews we've done, is guests mentioning how being on the job and having the job inherently exposes you to coworkers who are invested in you succeeding.
Yeah.
And so, like you were describing, osmosis, or coworkers actively educating you up on job skills that are really valuable.
Yeah.
Just getting that first job is really key to being in a feedback loop where your coworkers will help you overcome educational hurdles you might encounter, but also cue you towards what topics are really important to be working on and learning how to be good at, I guess.
Yeah.
Since you moved out to San Francisco from Boston, have you been at Flux this whole time?
Yeah, the whole time I've been in San Francisco, basically.
What are kind of the skills differences that you see in working at Flux versus having worked at EverQuote, the startup in Boston?
So when I first started at Flux, I wasn't a backend software engineer. I was I guess like an app engineer is what I would call it. So working on various projects closer to the front end, including like actually making apps, or web apps I should say, but also making like tools to support people making web apps. So kind of that area of things, but slowly over time I've kind of transitioned a little bit into now being like essentially working full-time on backend services and stuff. So that's been an interesting transition. First of all, it was kind of an interesting transition being on the, going into being a kind of app engineer, having been a data analyst type of role at EverQuote, because I'd only just really learned like web development skills, so there was a lot of groundwork to cover there as well, fresh off of having learned, covered a bunch of ground just to get into the first job.
Mind getting specific? Like what application development
so
skills did you have to learn when you came to Flux?
So I think there were two really big ones. One was learning the quirks of browsers. They're just really odd kind of pieces of software, and you have to work around their quirks a lot. I don't love doing that. I wouldn't say it's like my true calling is to like make web apps, because a lot of the time I think like, why did we make browsers this way? They're so arbitrary and weird. Like, what's the deal? But that was definitely a thing. There was a lot to learn there in terms of I think you can, anyone can throw up a website. It's intentionally meant to be a kind of like low bar to entry, but to sort of productionize things and make them, to do a professional job on making a web app, I feel like there's a lot of knowledge actually that you need to have to ensure that your browser is going to be interacting with your server properly and like securely and efficiently. And
do you mind getting specific? Like what specifically were you really surprised by in working on the app side of things?
Probably the most surprising thing was how much of a hodgepodge security is in browsers. And it's gotten a lot better in recent years. I mean, I'm glad I wasn't working on this kind of stuff in like 2007 or something, because it was even more of a chaotic mess then. But there are a lot of things that feel like duct taped on, afterwards as an afterthought of like, oh, this is actually a security hole, and we're going to add this new feature to the browser to patch this security hole.
Dang, what were you guys building app-wise that was so security wrought?
That's the thing. We're not even trying to build something. I mean, obviously, like these are our clients are construction and architecture firms, so their data is kind of sensitive. Like they don't want just building not kind of sensitive. It is like they don't want building blueprints just going out to anyone in the world, right?
Yeah.
So they need to have a secure platform, but that's true of most industries. I think people care about their data not being exposed to the entire internet. So we weren't trying to do anything particularly special, but If you want to prevent someone from, doing a clickjacking attack where they can, show a kind of fraudulent page to your user, and then the user clicks on something and suddenly it's sent like the credentials through to your service, and then like taken some action on behalf of the user without them realizing it. If you want to prevent that kind of thing, you have to do one kind of mitigation. There's like another kind of mitigation for like, evil websites, using resources from your page to make legit looking, evil websites that trick users and stuff like that. Then there's all kinds of ways of like how do you secure cookies? Like there's a lot of ways to do it wrong, as it turns out. There are a lot of ways to do like authentication wrong. There are a lot of ways to do like data security wrong, and so
were these realizations about the security side of things that your coworkers were pointing out to you about the software you were developing, or were they things that you were discovering yourself?
Mostly coworkers pointing it out. Yeah. It was mostly that like we had already committed to doing a certain set of security things, and so then the actual process of implementing those things turned out, in some cases to be like tricky. That there was some amount of learning to be done about like, why do browsers do it this way? What exactly is going on here, and why was that the decision made? So
fair enough. Yeah.
So yeah, that was one. It's not. Again, I don't feel like it's fundamental knowledge about computer science, which is the stuff that really kind of gets me going. It's more just like dealing with a platform that has its own quirks and everything, like any platform does. But it's definitely it can get, it's a broad topic, I would say. There's a lot to learn there, and not all of it is super well connected or well integrated.
For sure. Well, it sounds like you went from being a back-end engineer at EverQuote to being more full stack and touching the front end a fair amount. Based on the security stuff you're describing, all of that sounds, well, A, it sounds really rough, but B, it sounds like dealing with browsers is a massive headache. And
totally, yeah.
Would you recommend for people who are starting their careers, maybe haven't gotten their first job or at their first jobs, to forego trying to work on the front end side of things?
Not at all, yeah. I wouldn't say like, forego it. I mean, every platform is going to have its quirks no matter what you're developing for. And at some point, you probably want humans to interact with your software. Maybe not if you're just writing like stock trading software or something. Sure. But if you're going to have, your software be used by people, then you're going to be developing for a platform that involves interacting with humans. And that is going to have quirks for sure. And it's because humans are weird, or maybe computers are weird, depending on your perspective. Yeah.
What are you hoping to work on in the next 5-10 years? Presumably as a software engineer, or do you see yourself moving into a different type of role with relation to your career?
I see myself doing software for the foreseeable future. I recently took a class on compilers, which really interested me. So I'm trying to explore that further, get deeper into that. I would like to at some point soon, think about designing language, and what that would involve.
For our audience that doesn't know what a compiler is, do you mind breaking down for our audience what is a compiler and why is it important to software engineering?
Yeah, so I guess you can think of a compiler as kind of Google Translate for software languages. So it takes language A and turns it into language B, and hopefully preserves all the meaning correctly. We all know Google Translate isn't perfect, right? So there's always quirks there, and that's where it gets messy. But the basic idea is you have language A, which is typically in our world is something that humans are going to be writing. So it's Java or C++ or something. Something that's hopefully got good enough abstractions and kind of clean enough syntax and everything that a human is going to be happy writing it. And happy is again subjective, right? But
so I know this is a fucking landmine of a topic, but what, in your opinion, are good language features? Like what makes a programming language to you more human friendly?
That is a huge landmine of a topic, and it's, I don't know, I'm going to give you a straight up engineering answer and say you're looking at a bunch of trade-offs there, right?
For sure.
So there's a couple of big trade-offs. I should say, first of all, back to just quickly to reiterate what a compiler is. So language A is going to be something human writable and readable. More importantly, readable, I think, is the kind of consensus these days that we do a lot more reading of software than writing. And so it should be something that you can read and understand what it's going to do. And then language B is ideally something that a machine can execute, or if not, then something that can easily be translated by another compiler into something a machine can execute. When I say a machine can execute, I mean this is like bytecode that you give it to your CPU and it runs it. Or bytecode that you give to a virtual machine, which is kind of like a fake CPU.
Okay.
A virtual CPU.
So what makes code more human readable?
Yeah, so like with any human computer interface, HCI is the cool word, but user interface, basically. A programming language is a user interface for programmers. The key thing is information hiding, not showing too much at once, because we model humans can only hold so much information in our heads at once, and it seems like there's kind of a hard limit to that. Like, unless you're a genius or something, that you can hold a shopping list worth of things in your head at once.
Arguably, geniuses are inefficient in that they're trying to hold more, or they're capable of holding more in their brain than they necessarily might need to.
Yeah, maybe they're doing it wrong. I don't know.
Basically, I'm saying geniuses suck.
Yeah, geniuses suck.
Keep going.
Yeah, we don't need those geniuses at all.
We need languages that are dummy friendly.
Dummy friendly. Yeah. Well, we got them. No, I'm kidding.
Python, yeah.
Python's not.
No.
Well, actually,
Python.
dummy friendly. I don't know. I would say Python is just friendly.
Agreed.
Yeah.
So, I'll weigh in on
sure.
something programming language wise that specifically Python I love is the white space.
Okay.
I think one of the great aspects of white space being, and by white space I mean tabs and spaces that help indent your code so you can see the flow of where your software is going line by line, is that by requiring indentation of code as a property of the language, you basically get punished if you indent your code too much. And as a human, reading heavily indented code is very hard to interpret because you might have conditionals like if else, you might have loops like for loops or while loops. Mm-hmm. And the more indented your code is, the less human readable it is. So one aspect of Python's white space as a property of the language is that it punishes bad programmers. And it penalizes you for heavily indenting code. And while you can style-wise enforce indentation and white space in the same way for other languages like Java, C#, JavaScript, Erlang, Ada, whatever, every language, Python, it's a built-in property of the language, and I think that makes it a very attractive first language for people to learn, or for companies to adopt as their application layer programming language. But that's my super heavy-duty opinion.
You jumped right in the minefield there. I feel like I
don't think it's even that controversial. Yeah.
Ooh, I don't know. I feel like there's a lot of people who really hate the white space. I'm not saying I hate it. I don't really mind it either way or whatever. But I've definitely met people who just despise the white space thing.
Okay.
I think because the way they see it, these are usually people who are happier writing C++ or something. Because the way they see it, they're like, I don't want the language to tell me how to style my code. I want to style it however I want to style it, and it should all be able to run in one line if I want it that way. But,
okay. Usually, but I think I don't like working with those.
Yeah, so they can be hard to work with. Yeah.
Sure.
I think that it's about taking cognitive load off the programmer, and so the example you're giving is like having the code follow a kind of uniform format, be it white space or whatever, whatever kind of syntax like the language chooses to help unify the representation of code. That takes some load off the programmer because they know what to expect. When they see even a certain shape of code, they kind of start to imagine what it's going to be doing, which is why you see like style guides. In the JavaScript world right now, there's like a hot thing to do is like have a style guide that's going to like either lint your code and like tell you when you're doing things that don't match the style guide, or it's going to automatically restyle your code for you, so that everyone just writes however they want to write it. They run this thing that restyles it, and now it looks like the way that we all want it to look.
So that's actually a topic that's come up previously. We had a guest on, Anand Kulkarni, who's CEO of a crowdsourcing business for software development, where I was asking him about what acceptance tests, what criteria do they have in place as requirements for whether code is good or not.
Yeah.
And the type of tests that you're describing of linting and checking whether the code that a human has written conforms to a style guide is of the type of test that's called a static analysis. This is a common, I guess not metric, but static analysis is evaluating code in its human readable form to determine whether there are errors that can be inferred.
Or even potential errors, maybe.
Or even hypothetical potential errors that might be present without even having to run the code in its machine readable form.
Yeah.
So are there properties of programming languages that make certain programming languages more or less amenable to this type of static analysis, where you can get feedback about what a human has written in the programming language without having to run it?
Yeah, I mean, absolutely. This is like one of the number one kind of, I guess, like design choices to make if you're going to make a programming language, is how much static analysis do you want to do? Generally speaking, the more amenable your language is to static analysis, the more explicit the program is going to have to be when they're actually writing things. So like, a language with like strong and explicit types like Java or something like that, in any given expression or block of code, like whatever the type of what everything is. And so when someone tries to like add an integer to a string, it can maybe cast it or something fancy, but generally you would just say that's an error. We didn't even have to run that line. We know it's an error. So like, fix it. So yeah, that can be a really great property. People also see it as a limitation because you have to write more stuff down in the process of making code. Whereas, if you're using Lisp or something, or something, some incredibly flexible language, you can write shorter programs. You can write, really concise, cool one-liners. You don't have to write as much stuff down, but it's not going to be able to tell you, at least unless you develop some really, really hardcore static analysis tools, it's not going to be able to tell you about errors before it runs them, generally speaking.
So how did you, if not in your undergraduate degree, get familiar with this topic of programming language design? This is a topic that comes up a lot on our show, is about how do you learn things beyond a formal education?
Yeah. It's a hugely challenging thing. I would say that very early on, like I said, there was YouTube, there was co-workers and colleagues. I should have mentioned I worked through a textbook when I was first at MX as well. It's like a classic computer science textbook called Structure and Interpretation of Computer Programs. Sure. Plug that one.
And it's freely available. We'll include a link in the show notes.
Yeah, it is, and it's a really good one. There's also like OpenCourseware, which is MIT offering. So like any not even software engineering, computer science lectures that you want, you can find there. But recently I took a course from a small, I guess, school, you'd call it, called Bradfield Computer Science or Bradfield CS, I think they call themselves. But they basically offer classes for, currently employed, like, full-time software engineers, basically. People who are not trying to get into software engineering like the way a coding bootcamp might work, but people who are currently working and want to go deeper into various parts of the field, I guess. So they offer courses on things like compilers or distributed systems or that kind of thing. Generally like topics they're not really beginner topics. They're sort of like, you need some groundwork before you would be able to make sense of a course like that.
For sure.
But yeah, so now I'm a couple of years into this world, and so I felt ready to try and take a course like that. So I took compilers. We worked from this scary looking textbook called the Dragon Book, which is a notorious textbook in some ways, like notorious for being like comprehensive, but also maybe a little hard to parse sometimes, hard to read. But
I like the pun.
see, yeah. But actually, I think it's a pretty good textbook, and there's enough like supplemental beginner level stuff that you could read online that it's good to have a reference kind of book around like that as well.
For sure, for sure.
So we worked through, from the start of language design all the way down to, running it on a machine, a VM, whatever. So that's all the way from, like you said, static analysis, lexing, parsing, semantic analysis, which is like the part of the compiler pipeline where you do type checking and that kind of thing. Then onto, like bytecode generation. And so we like implemented a VM to do that. And then, once you've implemented a VM, you're kind of done, but in a...
VM being virtual machine?
Virtual machine, yeah, sorry. So that's one approach that you can take. Another one would be to like directly compile to a real machine target, like Intel's assembly language or something. But it's a little easier to implement a virtual machine in some high-level language that you're comfortable with, because that way you know what's going on inside it. Whereas reading through all of like Intel's assembly documentation can be it's just a whole other thing to learn. So we tried to keep it a little simpler than that. So yeah, that was like roughly what the course covered, but it was just very inspiring, and it introduced me to a lot of even just terminology that I wasn't totally sure what it meant. Now I feel like I at least know what if someone asks me a question like, what, how does this part of a compiler work or something, I would know what to Google now, which is a really key skill.
That's the first step to
Oh, it really is, yeah.
Before we started recording, you mentioned one of the skills that you discovered that is possible to learn that you hadn't known or been familiar with before taking the compiler's course is familiarity with LLVM.
Mm-hmm.
For an audience that has never heard of LLVM, do you mind giving like a very broad 10,000 foot overview of what LLVM is and why it's worth learning and why you're interested in it?
Yeah, I'll give you the 10,000 foot overview because I feel like the level of detail to which I understand LLVM is probably like the 5,000 foot overview. So it's great. You've asked me the perfect question. So LLVM is it sounds like VM virtual machine, right? And it kind of is that, but it's also kind of a library for doing code generation for any machine target that you would want. So LLVM doesn't stand for anything, I don't think, but it originally was meant to stand for low-level virtual machine. So it kind of has two components. One is a virtual machine, which I don't think is used very often. The other is code generating from LLVM's intermediate representation. I should explain what that is, but I'll get there. To like whatever assembly target for whatever machine that you actually want to run stuff on.
Before we get further into the details, I think it might be worthwhile to kind of share for the audience why this is a tool worth even attempting to understand.
Yeah, okay, so zooming out even further.
So zooming out even further, LLVM is a framework for writing programming languages or writing compilers, I guess.
I wouldn't even say it's a framework for writing programming languages. You remember when I was talking about, so compilers take language A and go to language B, sort of thing, and then so language B, LLVM implements a language B that you can compile your language A to. So A can be some like crazy, functional whatever, the next Haskell or something that's got some really complicated features that you want. Yeah, exactly. LLVM provides what they call an intermediate representation, but it's just another programming language, but it's somewhere between like C and assembly in terms of complexity. Like it's got some features that assemblies don't have typically, or like are a little harder to implement, but it's also low level enough that it can easily be translated into really tightly optimized machine code. So basically, if you write a compiler that goes from language A to from your pet language to LLVM, then LLVM has all this like really hardcore, like best in industry optimizations that they can apply to that intermediate representation to generate machine code that's going to run really fast.
So one example use case in the real world of LLVM is, I guess, the familiarity I have with it is Apple's use of it as a component of their compiler of Objective-C
Yep.
to assembly language code that runs iOS apps.
Yeah.
I'm sure there are many other examples, but if people need a rationale for understanding its value, the fact that it's a component that is essential to running all apps on your iPhone or iPad is a pretty reasonable argument for trying for understanding it and seeing why it's valuable, I guess.
Yeah, totally. And I mean, if you're just writing Objective-C, you probably will never actually have to interact with Llvm specifically, but it can be interesting if you want to know why this piece of code is running fast or slow or something. Could be interesting to take a look at what Llvm code is actually being generated from the code fragment that you're wondering about.
So Xcode, the IDE that Apple provides for writing iOS apps. I don't know how much they hide LLVM under the covers when you're writing your Objective-C in Xcode, but the guy who created LLVM or headed up the LLVM open source project was a University of Illinois professor.
Okay.
He got hired on full-time at Apple, and then I think he left to join Tesla. And now
all over the place.
He's been a huge advocate for LLVM's use in the development of the iOS platform and for running native mobile apps. But my familiarity with it is very low. This is the most intense conversationally on the show. We've gotten into computer science theory topic. I feel out of my depth.
I feel like I could point out one more reason why you might want to use Llvm. And again, like, I wouldn't say I'm an expert in this or anything. This is just what I've learned from like one class, basically. So,
sure.
But because it's backed by big industry players like Apple, and I think there's a few others even, you get kind of a lot of like really hardcore industry optimizations and performance and like robustness for free. So instead of trying to turn your next Haskell or whatever into like Intel assembly language or x86 like assembly, which can be really hard because you're going from some really high level, like almost mathematical notation down to like instructions for a machine. If you use Llvm, you can get a lot of the optimizations that the big players get for free. And so that would be a reason, if you were planning to design a language, which I don't know how many of your audience members are into that, but maybe, maybe people don't even realize it's a thing they could do. Like anyone can get in and just make up a programming language. Like that's how we got all of our programming languages, actually, was by and large people just making them up because they thought they should exist.
And even if you're not setting out to create your own programming language, there are tons of jobs at places like Apple or Google or what have you where these large corporations are backing programming language development or design.
Yeah, absolutely.
In order to optimize those languages that they have available for developers to develop apps on their platform, in order to make them super optimized and preserve things like battery lifetime for phones, all kinds of levels of detail. That's a huge one,
that's actually one area that because Apple compiles all their apps down to an almost machine code like level before they even send the app to your phone, which they can do because they know what hardware they're going to be running everything on, because it's Apple, right? There's like one piece of hardware for all the, for everything. That's one reason why like iOS apps often are better at using energy and like can be faster and do more crazy graphic stuff than Android apps, because Android, there's actually a VM, a Java like virtual machine running on your Android phone all the time, like interpreting the like compiled version that you got off the App Store to run on your phone's hardware, which is something that like the App Store has no idea about. It doesn't know how your phone's CPU works, because it could be made by anyone, right?
So there's a layer between the app that you get from the Android App Store and what actually runs on your phone.
Yeah, in a way that there isn't really that layer on iOS. So definitely, like that's a thing that a lot of it's a reason why Android will probably never be quite as like efficient and fast as iOS, and at least for like really cool applications like graphic stuff. At least until Android.
People might disagree.
Yeah, they might disagree, and they might come up with some new technology that mitigates this. It's totally, it's not like a done deal, I guess. But
so to wrap, is there anything that you'd like to plug in terms of tools or resources that you think our audience would find valuable for learning how to get to a point in their careers that's similar to yours, job-wise, career-wise, skills-wise?
Yeah, totally. One thing that I would like to suggest everyone do is last week I just got back from a conference called Strange Loop in St. Louis, Missouri. It's actually the second time I've been to it. I went once last year and then again this year, and each time it's been like a really inspiring and awesome experience. Just in terms of opening my eyes up to what is out there. I learned things that I didn't even know existed, didn't even think to imagine would have existed, sort of thing.
Sure.
So it's like just a really good opening up of horizons and perspectives and stuff.
And even if you can't attend the conference in person,
yeah, you can look it up on YouTube. All the videos are on YouTube, which I recommend you do. And they have records back to the beginning, I think. So
we actually have a video with another EverQuote person, Kyle Feely, director of user experience, who has a bunch of tips for employees to provide arguments to their managers on why they should be allowed to go to conferences or why their employer should fund their
cool. I
trips
should
to
watch
conferences.
that because that's
Clutch.
that's key, yeah.
Well, dude, Tom, it's been a pleasure. Thanks for coming on.
Yeah, thanks, Max.